Hello, it's Mrs. Mallet again, and there's no really video for the Appendix G that we're starting off this week, so I figured I would actually do a video for you guys to kind of see how to do the assignments. And so I have the book pulled up here, and we're going to go through the book, and then I'll write some stuff out too. So Appendix G talks about functions. So in this we're going to introduce the concept of functions. Okay, so we're going to talk about what is a relation and what that means, and then we're going to talk about what is domain and range. And then we're going to talk about how we use functions. So, I have the book open, and I'm going to read from it and kind of put in my own 2 cents. So, let's consider this specific example. Suppose a hospital keeps record of the birth weight, lengths, and weights of babies born in the maternity ward. One night, 5 babies were born with the different lengths and weights shown in the table. Okay, so we have these birth lengths right here, and we have their corresponding birth weight. So now they plotted those on a coordinate plane to get a better sense of the trend. Okay, so here's the trend. Now, whether expressed in a table or in a graph, the given information defines a relation between the birth length and the birth weight. Okay, so how can we think of that relation? Well, look here. This one right here, this blue dot right here, corresponds to 30 and about 2.3. Okay, so 30 and 2.3 would be considered the relation. And so notice that's this one right here. Okay, this next one would be about 46 and 3. Okay, so notice here these are relations, and so notice the relations are also ordered pairs, which brings us to our first definition, is that a relation right here, a relation is a set of ordered pairs. So I'm going to circle that. That's the first definition that we need to understand regarding functions, is that a relation is a set of ordered pairs. Now, what the hospital has here, what they defined, is they defined a special kind of relation, and that's called a function. Okay, so right here, they called it as a function. Okay, we know it's a function because if you look at all the first coordinates, so look at all the birth lengths, which are also on the x-axis, notice those are all different. We have 46, 58, 48, 30, 52. Notice they're all different. Okay, so if one of them had the same, so let's say we had 46, 48, 30, okay, then it would not be a function. So now let's turn the page. And at the top of the next page, it talks about what a function is. And a function is when you have a relation, which we already learned a relation is the ordered pair, is which no 2 ordered pairs have the same first coordinates. Okay, so a function is when you don't have the same first coordinates when you have a list of ordered pairs. Alright, so with the different birth lengths, because they all had different first values, different x values, in other words. And remember, we're talking about ordered pairs. That's an x and y. So, but they all had different numbers there, so that actually meant that those were a function. Okay, so now let's look at practice 1. We're going to do the practices here on the right-hand side. Look at practice 1. So it says decide whether each relation represents a function. So we have, look at all the first numbers. Okay, so I have -5 here. I have -2. I have 0, 3, and 0. Do any of those repeat? Yes, my 0 right here and my 0 right there. Those 2 repeat. So would A be considered a function? No, it's not a function because you have 2 zeros right there. Now look at B. Remember, you look at the first coordinates. So B, 4, 2, 5, and -1. So based on the definition, remember you cannot repeat the first x value. So those have different x values. So we would actually say yes, that practice 1B is a function. Okay? So now that we understand what a function is, remember a function, once again, is a relation in which no 2 ordered pairs have the same first coordinates. So now we're going to talk about what it means to have a domain and a range. Each function has a domain and a range. The domain of the function means that you list all the first coordinates that are in the ordered pairs that make up the function. So the domain pretty much is all the first numbers. So your domain is the first numbers. Okay, so it's the first numbers in the ordered pair. Okay, the range is all of these second coordinates right there. So your range is the second coordinates, which is the y values once again. So the domain is the first coordinates and the range is the second. Okay, so now let's look at the next page and let's identify what the domain and the range are. Okay, so notice now we're going to talk about the definition of domain and range. Like was on the other page, we're going to reiterate on this page as well. So the domain is all of the values of the independent variable, which is also all of the first, in the ordered pair, it's all the first values, or the x values. The range is the dependent, also known as the y values, or the second values within your relation, which is also your list of ordered pairs. So let's look at practice 2a. So notice here we have a relation here, 2, 0, 8, -6, and 5, 3. And in this one, what we need to do is, and I have this up here, so I'll move this right here. So what we need to do is identify what the domain is and what the range is within this relation. So my domain is all of the first values, or the x values. So it would be 2, 8, as well as 5. Okay, those are the first values, or the x values. So those are the domain. The range is all the y values and second values. So that would be 0, -6, and 3. So that's how you identify what the domain is and what the range is. Okay, so let's look at practice 2. So let's scroll down here. And it says, 2b, the function determined by the following graph. So let's identify the domain and range of this graph on 2b. So notice on 2b we have 3 dots here. And first what we need to understand is we need to figure out, okay, what's the ordered pair of these dots? So let's look at this dot right here. Let's look at that one. What's the ordered pair of that one? Well, that ordered pair would actually be 1 and -1. So our first ordered pair is 1 and -1. What's the second ordered pair? Well, it'll be 2 and then 1, 2, 3, 4. So it'll be 2 and 4. Okay, so that's our second ordered pair. And the third ordered pair would be 2, 3, 4, 5, and 2. Now that we figured out what the ordered pairs are, we should be able to identify what the domain is and what the range is. So the domains are the x values. So that'll be 1, 2, and 5. So then my range values would be -1, 4, and 2. Okay? So if you look at the following table, once again on C, it says here, let me move this out of the way, it says identify what the domain is in the range. Well, the domain would be the days of the month, and then the range would be your hours of sleep. Okay? So that would be the first one would be your domains, and the bottom one would be your range. Now another way to think about functions is it talks about in function notation. Okay, so when it talks about independent and dependent values, that's pretty much your domain and range. But just know that as far as a rule with functions, is that to each value of the independent variable, you get a dependent variable with it. So what that means is, I kind of think of it as like an input-output machine, kind of what it says here, like a soda machine. If you were going to go get a soda, let's say we want to go get a Coke. Well, in order for us to get a Coke, we need to input our 50 cents into the machine. That's the independent variable. You need 50 cents. With my 50 cents, I'm going to get back out that Coke. Okay, so that's kind of how you're going to think about functions, is what you get in is exactly what you're getting out. But you can also think about functions when you write it as an equation. So if you turn the page here, and at the top of the page it talks about function as an equation. Now one rule of thumb is that if function notation, so for the most part we've been understanding, if you think back to graphing, we've been understanding graphing to be something like y equals 2x plus 1. Okay, that's an equation that we can actually graph if we were talking about graphing. Well, as far as functions are concerned, what they do is they replace this y right here, and instead of saying y, even though it's the same thing, they replace it with what's called f of x, and that's how you say it. Okay, so it's f of x, that's the function notation. So all this means is, okay, so the function of, and they'll give you, in some cases, at least for this, they'll give you the value of x that you're going to put in when we into this equation. So they'll give you like your 50 cents as you're doing this. So they'll say what is the value if I put in, let's say 2. Let's say I wanted to do f of 2 into that equation. Okay, so that what that means is instead of it being x right here, you're going to replace this x with 2 and figure out what this equation will give you. That's what this means in function notation. That's what that means. So in my example here that I made up, it'll be 2 times 2 plus 1. And then of course you would do that. So 2 times 2 is 4, and 4 plus 1 is 5. So if they give you 2 to input into the machine, this function equation, then your output would be you get a 5 by plugging that in. That's what function notation means, okay? Especially when we're talking about So let's look at these two. We're only going to do A and B. Okay, so our equation right there is you have 3 of x minus 1. So we're going to start by plugging in the value of 2. So now let's plug that in. So I'm going to pull up my other and turn the page here. So I'm plugging in the value of 2. So I'm going to plug in g of 2, right? That's what we're doing. So it'll be 3 times 2 minus 1. Well, 3 times 2 is 6, and 6 minus 1 is 5. So my answer here would be 5 for plugging in the value of 2. Now let's go through and plug in negative 1 right here. Okay? So let's go through and plug in negative 1. Now, by going through and plugging in negative 1, do the same thing. So it'll be 3 times negative 1, because you're plugging that in for x, minus 1. So 3 times negative 1 is negative 3, and negative 3 minus 1 gives you negative 4. So these are the different values you get when you plug in 2, you come back out with 5, right here. And then when you plug in negative 1, you come back out with negative 4. So in function notation, that's all this means. Now we're not going to do C and D, because I didn't give you any homework assignments like that. Now notice here in the example, they have f of x, and then notice over here in the practice it has g of x. Just know that the letters F, G, and sometimes even H are used to represent functions. It all means the same thing. So you're still going to plug in whatever value they give you and solve for whatever it is they're asking you to solve for. So that's just so you know that when you say an F or G, they all mean the same thing with functions. All right, so let's turn the page and now look at page 42. Now there are several different types of functions, and I'm just going to talk about these through them with you. Now, if you don't have homework about it, but I do know in college algebra they actually talk about these different types of functions, and you will do more with it. But there are different types of functions with respect to graphing. The first one is identified as a linear function, and obviously the root word in linear is line. So a linear function will give you a line. Okay, so just like we learned how to graph, those are linear. We can also call those as linear functions. Okay, so you do have right here the constant function. The constant function, that's talking about when you have a straight line right here. So when you have like a y equals equation, that's also known as a constant function. And then we more in graphing. We're not going to graph really this semester, but that's what that means. It's a function that you get a horizontal line from. It's a constant. So and notice both of these are linear functions because they give you a line. Now we're going to go to a rational function, and a rational function is when you have a graph that kind of looks like that. And so notice here you have two different types of drawings, I guess, on the graph. You have one in this top quadrant, quadrant 1, and then you have another one in quadrant 3. And if, I just want you to be familiar with what they look like. Now we will talk about rational functions and solving them algebraically, but if we were to graph them, this is kind of what they would look like, so you know. The next type is called a quadratic function, and a quadratic function is when you have an x squared. And on a quadratic function, if you turn the page, notice a quadratic function gives you something that is U-shaped. Okay, so a quadratic gives you a U-shaped. And then last but not least, you have what's called an absolute function. And an absolute function normally is when you have the absolute value. And we will talk about absolute value equations rather soon. But notice an absolute value function, if you're graphing it, it gives you a V shape. Okay, so it gives you a V, perfectly symmetrical V. Okay, now we're not graphing any of these, so we don't have to worry about this. But let's go, and now we're going to talk about the vertical line test for functions. Okay, so let's turn the page and get through these. Okay, so now on page 45 it talks about the vertical line test. Now the vertical line test is a way for you to look at a graph and now I'm going to read it, so if you look at this book, this little block right here. The vertical line test is if any vertical line intersects a graph at more than one point, the graph does not represent a function. If no such line exists, then the graph represents a function. So what that means is you draw a vertical line. So let's look at example 6a. Draw a vertical line, and you can kind of use the y-axis really as your vertical line. Okay, I just draw a vertical line anywhere, but you can use the y-axis as your vertical line if you need to. But just kind of draw a line anywhere. So now here, I drew a vertical line, and notice how many times do I touch this graph? I actually touch it right here, okay? So right there where I'm circling it. And notice I only touch it once. So if we were looking at these examples here, example 6 would be considered a function. So I'm going to put y for function because it only touches it one time. However, if you look at example 6b and you draw a vertical line, okay, so let's draw. Now you can probably think, well, you have to use the y-axis again, it only touches it one time. But actually kind of look at it. Okay, draw your vertical line kind of through it. How many times does my vertical line actually touch? Because you actually want to draw your vertical line through the graph. How many times does my orange line touch the blue? Well, it touches it twice, right there and right there. So because it touches it more than once, the graph is not a function. So we would say no there. So now let's look at practice 6. If we draw a vertical line through that circle, would we consider this to be a function? No, because it touches it twice. It touches it right here, and it touches it right there as well. So that one is not considered a function. And then now let's do B. So if you draw a vertical line through B, just anywhere, would you consider B a function? And yes, you would consider B a function because it only touches it one time. And you can draw more than one vertical line in here, but you'll still notice that it's only, well, that was horrible. But you'll still notice that your vertical line here still will only touch it one time. So you can draw more than one vertical line through it, and you'll notice it'll touch one time. Okay, so this is a little intro video talking about functions. I know there's no video for functions, so hopefully this video kind of helps you when you do your homework and stuff. And please let me know if you have any questions. I am more than happy to send you a video outlining the different topics and going in more further detail with these. I have no problem sending you a video, so please let me know if you have any questions.